Have you ever wondered about the electrical systems that keep an aircraft functioning smoothly in the sky? These intricate web of wires and components are the lifeblood of modern aviation. They power up everything from the cabin lights that illuminate your flight to the landing lights that guide the airplane to the tarmac. They operate the instrument lights that help pilots navigate, the starter that gets the engines revving, and the electric flaps that control the aircraft's speed and direction. But that's not all. The radio that enables communication, the transponder that sends out identifying signals, the navigation system that plots the course, and the electrically retractable landing gear that tucks away after takeoff, all rely on this electrical system. Most modern airplanes use what's known as a direct current, or DC, electrical system. Without the electrical system, an aircraft would be like a bird with clipped wings, unable to operate at its full potential. Most aircraft use direct current for their electrical systems. But what exactly is direct current, and how does it differ from alternating current? Direct current, or DC, is a type of electrical current where electrons flow in a single, unchanging direction. This contrasts with alternating current, or AC, where electrons oscillate back and forth around a central point. In the realm of light aircraft, alternating current is primarily used for power generation. However, in commercial aircraft, where the demand for powerful, reliable, and efficient installations is higher, alternating current is more commonly used. The intensity of this electric current passing through a conductor, such as an electrical cable, is measured in amperes with an instrument called an ammeter. The pressure difference required to get these electrons moving along a conductor is known as voltage, and this is measured in volts with a voltmeter. While direct current is the norm in most aircraft, the choice between direct and alternating current depends on the specific needs and functions of the aircraft. So, we've got our electrical current, but how is power generated and distributed within an aircraft? Let's dive right into it. Voltage can be generated in several ways, but in light aircraft, the primary source of voltage is typically the generator or the alternator. Think of the generator or alternator as the heart of the electrical system, pumping out electricity when the engine is running. But what happens if the heart stops, or in this case, the generator fails? That's where the battery steps in. Much like our heart's backup system, the battery can support the aircraft's essential systems for 30 minutes, in case of alternator or generator failure. This gives the pilot enough time to find a safe place to land. Now, we've talked about voltage, but what about power? Electrical power is defined as the product of voltage and current. It's measured in watts, named after James Watt, the Scottish inventor and mechanical engineer. The equation is simple. Power equals voltage times current, or P equals V times 1. This equation allows us to understand how much power is being consumed by a device, or how much power is available from a source. So, we've generated our power. Now, how do we distribute it? Enter the bus bar. The bus bar is the distribution center of the electrical system. Imagine it as a bustling city hub with electricity as the commuters. The bus bar allows electrical current to be distributed to various circuits or units, much like a train station allows passengers to reach their various destinations. From the alternator, electricity flows to the bus bar, and from there, it's distributed to the various systems and components that need it. From the lights in the cockpit to the landing gear, each system gets the power it needs, when it needs it. From the generation of power to its distribution, the electrical system of an aircraft is a marvel of engineering, ensuring that all systems have the energy they need to keep the aircraft flying safely and efficiently.